number 6, understanding irrational numbers. Learning target number 5. I can plot, and we're going to be able to compare irrational numbers on a number line. So let's look at our first examples. We're going to actually start with the plotting part. And so we're going to look at the square root of 17. And I'm going to do a little math over here from LT4 just to get my brain going. Even though we have gone through how to do some of this, we're just going to kind of look at a couple here. So the square root of 17, if I try 4, we know that's the square root of 16. If I try 5, that's the square root of 25. So we know it's between the whole numbers of 4 and 5, closer to the 4. So I'm going to use this lovely resource of a table that we gave you after learning target 4. And we're going to look at the low end of 4. So when I'm looking at this, I see 4.1. It's a little low. I look at 4.2 and it's a little high. So those are my two numbers I'm going to use here. Let me change color so I can see it. So 4.1 squared is approximately 16.81, and 4.2 squared is approximately 17.64. And again, I chose those two because that's where the square root of 17 falls between. Looking at the math here, we're going to do a little subtraction. So we're going to take 17 minus 16.81, and that is 0.19. And of course, 17, I don't know why that keeps changing, 17.64 minus that 17 is a 6,400. So 1,900 is as closer. So our estimate for this value is approximately 4.1. So now we're going to decide, so we've done this part, so locate the two whole numbers that the square root of 17 is between, look at the 10th place, which is what we did, is 4.1. Now we're going to decide what tenths. And so notice that these number lines that we're going to give you are in tenths. So for example, if we look at this, this is 2, and then 2.1, 2.2, 2.3, 2.4, 2.5, 2.6, 2.7, 2.8, 2.9, and of course we go to our next whole number. Again, I can show you that was 4.1, 4.2, 4.3, 4.4, 4.5, 4.6, 4.7, 4.8, 4.9, and then the whole number. So on this one, we're looking for 4.1. So we look at the 4, we go 1/10, so 4.1. We're going to label that with 4.1, and we're also going to label it with the square root. And again, that looks really good because up here we notice that the square root of 16 is 4, and the square root of 5 is 25. Next example, 24. So let's go through our steps. The square root of 24 is between 4 and 5, because the square root of 16 is 4 and the square root of 5 is 25. And again, we probably could put these down here if that helps you. Square root of 16 and the square root of 25. So square root of 24 is on the high end. So the high end of 4. So I'm going to use this table again, and I'm going to look at my table, and I'm looking for 24. So below 24, so 4.8 squared equals 23 and 400ths, and 4.9 squared is approximately 24.01. Now we're looking for the square root of 24. So this totally is different. I could do the math and I can do the subtraction, but I can only tell this is a 100th off. So I know that 4.9 is my best estimate for the square root of 24. So I'm going to go through my tenths here. So that's 4.1, 4.2, 4.3, 4.4, 4.5, 4.6, 4.7, 4.8, 4.9 here. So I'm going to make a big mark there, a data point, and I'm going to say that this is 4.9, and that's the square root of 24. Okay, next example. This time they want us to go back into learning target 4 and look at problems 1 through 8 and just kind of go through all of those and put them on the number line. So I'll give you a moment to turn back to problem 1 on LT4, which would have been our video notes. So when you turn, let's kind of keep some track here. I wish that would go away. Okay, so Number 1 was the square root of 5, which is approximately 2 and 2/10. So we're going to find that. Here's 2.1, 2.2. We're going to put the square root of 5 above that. Number 2 from our video notes was a square root of 13. The square root of 13 is approximately 3.6 or 3 and 6/10. So we're going to go to 3 and then we're just going to count our tenths. So there's 3.1, 3.2, 3.3, 3.4, 3.5, 3.6. So we're going to look at the square root of 13 there. And again, we can put it at the bottom. This is 3.6 just to be guaranteed. Again, this was 2.2. Number 3 was the square root of 22 from our video notes, which we found approximately was 4.7. So we're going to go to our 4 and count up 7/10. So 4.1, 2, 3, 4, 5, 6, and 7. And we're going to put the square root of 22. Number 4 was the square root of 7, which is approximately 2 and 6/10. I'm going back to this 2 here. So that was 1, 2, 3, 4, 5, 6, and 7. And that's the square root. Well, let me count that again. 1, 2, 3, 4, 5, 6. So I was counting the 7, so it should be this number. So that's the square root of 7 there. Number 5, that came from your practice. So that was the square root of 2, and the square root of 2 was approximately 1.4. So we're going to go to 1 this time, count 1.1, 1.2, 1.3, and 1.4. So that's the square root of 2. Number 6 was the square root of 23, which is approximately 4.8. So square root of 4, 1, 2, 3, 4, 5, 6, 7, and 8. I'll squeeze that in there. Square root of 23. A good sign is the square root of 22 is right in front of it. So we must be doing something right as we look at these square roots on a number line. Square root of 10 we found was approximately 3.2. So we're going to go to 3, 3 and 1/10, 3 and 2/10, which is the square root of 10. Make my dot a little bit bigger there. And then my last one was the square root of 6, and that was approximately 2 and 4/10. So back to the 2 here. 1, 2, 2.3, 2.4, 2 and 4/10, which is the square root of 6. It's really hard to read, but square root of 6. So notice, and that's a good sign here, square root of 5, 6, and 7 are all right there in a row, which means I must be doing something right. Now, if we kind of look at this, just to look at and compare, the square root of 1 would go there. So square root of 1, square root of 2, good sign. This is the square root of 4. And then we got 5, 6, 7. This is the square root of 9. And then 10, 13, square root of 16. And then 22, 23, and the square root of 25. So it's a really good sign that after I kind of look at those whole number side lengths or whole numbers, that I notice that the ones I placed in there are between them. And we could go through this and find the square root of 3 that we're missing here. We can go back and find the square root of 8 we're missing here. And, 10, that's 11, 12. We have 13, 14, 15, 17, 18, 19, and keep going. So when you do this, you should be able to put those square roots that we know that have whole numbers, and then those irrational numbers that we're approximating should be between them. The last thing we're going to do is we're going to compare. And there's 2 ways to compare. You either have to choose to put them all into square roots. So I'll write square roots here. Or you can choose to put them into their decimals. You have to put them in one or the other. To compare them. It's hard to compare if you have them in 2 different. So I'm going to start with the square roots here. So 6, I know that is the square root of 36. And then I have the square root of 45, square root of 30, square root of 59, square root of 49, and the square root of 64. So either put in square roots or we're going to put them into decimals. So my decimals here, 6 is already decimal, or we can put 6.0 if we want. Okay, next one, square root of 45. This is going to take a little bit more work. We can kind of look at our sheet. And when I'm looking at my sheet, the square root of 45, it's closer to 6.7. It's just not coming out right for us. So let me pick a different color here, see if this will work. 6.7, 6 point, actually, we'll just start over. Okay, so 6.0 and then 6.7 and 30. Going back to my sheet is 5.5. Square root of 59. Again, I'm looking at my sheet just like you would, is 7.7. Square root of, 7 is 7. And then the square root of 64 is a whole number of 8.0. So again, one or the other, and then you can just compare. So you can put them in order, or you can kind of just look at them. So first of all, it wants the lowest, and it wants the highest, or the greatest. So when I look at these in square roots, I'm looking for the lowest radican. So my lowest radican is 30. Yep, looks like 30. So radican is the number underneath the radical sign. So just to check, 36 is higher, 45 is higher, 59 is higher, 49 is 64. So the square root of 30, and we'll look at the decimal there. So we have the only thing in the fives. Remember, I put them in order so it's easier. Notice it's the third one over, third one over. So either the square root of 30 or approximately 5.5. And I knew that because if it's in radical form, it's the radican, it's the lowest radican. If it's in decimal form, it's the lowest value in my list. Again, let's do it with the highest. So looking at the highest, I got 45. I got, looks like 64. So let me just check. That's lower, that's lower, that's lower, that's lower, that's lower. So the square root is 64. And again, I know that, and I'm just answering this out loud, is because the radican is the highest. And I'm going to look at my decimals. I got 6, 6, not 5, 7, 7, 8. Well, it looks like 8 or 8.0, which we know is the square root of 64 is 8. So again, we know because this has the highest value.